everyone, it's Shamila here from Can Do Teach, and in this video I'm going to be taking you through the index laws and helping you to remember them by actually understanding why they make sense. So indices are what we call numbers that appear in this position, and we use it as a shorthand for how many times a number multiplies itself. So let's say we have x times x. Well, instead of writing x times x each time, I can write that that's x squared. So x to the power of 2 means x multiplied by itself twice. So similarly, x to the power of 3 means x times x times x. And you'll see I often use dots as multiplication or write nothing at all. So just to get our terminology straight, this number here can be called an index, or a power, or an exponent. And this number here we refer to as the base. And we can also have a number multiplying the whole thing, like 3 for example, and that would be called the coefficient. So it doesn't have to be 3, it's just any number multiplying the thing. And you should be clear that the power only relates to the base, not to the coefficient. Alright, so let's start by looking at how we add these things. So in addition, the only type of numbers that we can add are like terms. So we know that if we have x squared plus x, we can't add those two things because they're not like terms. So we just have to leave it like that. But if we had, say, 3x squared plus 7x squared, these two things are the same. So we can add them to give us 10x squared. All right, so as long as the base and the index are the same, then we can add the coefficients to give us the total. All right, so now for multiplication, we can think about what we would do if we had, say, x squared times x cubed. Well, we know that x squared is equal to x times x, and x cubed is equal to x times x times x. Now, when I've written it out like this, the brackets aren't really doing anything because everything's just multiplying. So I could get rid of them and just say times here. So now I can see that this is just the same as x to the power of 5. So what happened is that the indices actually added. So if I just count up x times itself twice and x times itself 3 times, in total I'm doing x times itself 5 times. So it's just x to the power of 5. So the rule is that if we have the same bases, the powers will add. So x to the power of a times x to the power of b will be x to the power of a plus b. Makes sense, right? So let's think about what happens with division then. So for division, let's say I had x to the power of 4 divided by x to the power of 2. Well, in this case, if I expand it out, I've got 4 x's on top and 2 x's on the bottom. And we know that we can cancel 2 x's on the bottom with 2 x's on top. So what that leaves is just the 2 remaining x's. So just x squared. So what happens this time is the power on the bottom gets subtracted from the power on the top. So I end up with x to the a divided by x to the b gives me x to the a minus b. That's it. All right. So what happens if I have a power to a power? So for example, if I have x squared to the power of 3. Well, then I know that's the same as x squared times x squared times x squared, because that's what cubed means. And then these 2's are all going to add up, because I know that when I have multiplication, then the indices add up. So I can write x to the power of 2 plus 2 plus 2, or I can write 2 times 3, because that's the same as 2 plus 2 plus 2. I'm just adding 2 3 times. So what happens is that these powers end up multiplying. So I get x to the power of 6. All right? So in general, if we have x to the power of a to the power of b, then all that happens is the powers multiply. So I get x to the power of a times b. Alright? So now let's think about what happens if we have a product to a power. So let's say we had x times y to the power of 3. Well, I know that everything in the bracket is being multiplied 3 times. So we go x times y times x times y times x times y. And now with multiplication, it doesn't matter which order I multiply in. So that's the same as x times x times x, so x cubed, and y times y times y, so y cubed. So all that happens is that this power actually gets distributed over everything inside the brackets, everything that's multiplying inside the brackets. So I just get x cubed, y cubed. So as a general rule, I can write x times y to the power of a will just be x to the power of a, y to the power of a, right? And the exact same thing happens with division or fractions. So again, if I had x divided by y squared, let's say, then that ends up being x over y times x over y. And I know with fractions that I just multiply the tops and multiply the bottoms. So I end up with x squared over y squared. So in general, if I have x over y to the power of a, again, the power just distributes, and I get x to the power of a over y to the power of a. All right, so those two are pretty easy to remember. The thing that you have to be really careful of is that it doesn't happen with addition. So if you have a sum to a power, the power doesn't distribute in the same way. So you can't just say that it's x squared plus y squared, okay? That doesn't work. So it's a really common mistake to write that x plus y squared is equal to x squared plus y squared. But that's not right, okay? If you remember, when we have something like this, we have to expand. And it ends up being x squared plus 2xy plus y squared. All right? So make sure you don't fall into that trap of thinking that the index just distributes over addition. It doesn't. It only works with multiplication or division. All right? So here I just want to make a quick note of what x to the power of 1 means. So x to the power of 1 is x times itself 1 time. So it's just x, exactly just x. Which means that times that we have just an x with no power, you can assume that there's a power of 1 there. For example, if I had x times x to the 5, well then I have to add the powers, but it looks like there's no power here. So I would say this is x to the 1, and then this ends up being x to the 6. Alright, so that's just a little something to keep in mind. So the final thing is the power of 0. So how do we make sense of x to the power of 0? Well, we can't really say x times itself 0 times. That doesn't really make sense. But what we can think about is what other index law might give us x to the power of 0. So if we remember the division law, well, we know that the 0 may have come from something like x to the 2 minus 2, right? And from the division law, we know that that could have been x squared divided by x squared, okay? X squared over x squared would have given us x to the 2 minus 2, and that gives us x to the 0. But this is something divided by itself. And we know that anytime you have the same thing on the top and bottom of a fraction, that fraction is equal to 1, right? So, x to the power of 0 is actually equal to 1. Make sense? So just to summarize, these are all of our index laws. So we know that when we've got the same base multiplying, then the powers add. If you've got the same base in a fraction, then the powers subtract. So the top one minus the bottom one. If you've got a power of a power, then the powers multiply. If you've got a product with a power, then the power distributes over the product. So each thing inside gets the power. And that works exactly the same if one of these things is a number. So if we had 2x to the power of 3, that would become 2 cubed x cubed. So 8x cubed. All right? Same thing if we've got division, the power distributes over the fraction. And finally, if we have x to the power of 0, that's the same as 1. All right? So I hope going through it that way helped you to make sense of all of the index laws and hopefully remember them better, and also not make the common mistakes. So let me know if you have any questions in the comments below. Otherwise, you can always get extra help at candoteach.com. Thanks for watching, and I'll see you next time. Bye for now.